Look at perfect squares, but in the form of trinomials and binomials. So what this is, there is a specific pattern that happens when we have a perfect square at the beginning and the end. Okay? The pattern with the signs is going to stay the same. If you don't like this shortcut, you can always do box. Okay? But I am going to show you this shortcut for perfect square trinomials. We have one where we have a plus in the middle for b and a minus in the middle for b. And then we're also going to talk about a difference of two squares, which, if you notice, does not have a middle. Okay? So this is what we're going to practice today. So if you'll open up your folding, we're going to talk about that pattern first. So the pattern says that when A is a perfect square and B is a perfect square. So we're going to make a little note. So this is a perfect square. And this one is a perfect square also. We're not really worried about the middle. It says that we can take the square root of the first term and put it as the first number in our binomial. And we can take the square root of the last term and put it in our binomial as the last term. And then we just have to look at our signs. Well, C is positive. What do we know when C is positive?
It's positive.
They're going to be the same, and if B is positive, then it's going to be a positive. And we would write that because it's a perfect square. We would write it twice. We can also see it as A plus B quantity squared. And I realize that when there's a bunch of letters like that, you're like, I'm going to write this. Doesn't make a lot of sense. We're going to do some with some numbers. Okay? So we've got a couple examples, and we're going to do this with the box first. You have a little bit of space over here. So let's draw our box. There's no GCFs on this first one. So when I draw my box, here's my x squared. Here's my 49. Okay, looking at C, are your signs the same or different?
Same.
They are the same, and they are going to be what?
7.
It's got to be a positive. So we have a positive x and a positive x. So when we think about A times C, our A is 1, 1 times 49, and we list our factors of 49, we just get 1 and 49 and 7 and 7. So which of these will give me 14 when I add? 7 and 7. Now I can take out my GCF. I know if it's x squared, it's x and x. Something times x is 7x. Okay, well, positive 7. Something times x is 7x, positive 7. Notice that the factors are identical. Okay, so we could write this as x plus 7 quantity squared. Okay, so the way the shortcut works, this first term, 1 is a perfect square. X squared is a perfect square. What is the square root of 1? 1. What's the square root of x squared? X. Look at your signs. We already said that they're the same. They're both going to be positive. What is the square root of 49? 7. And we would have to square that. Did we not get the same thing without the box? On this one, notice, yes, the first term is a perfect square, and the last term is a perfect square. What is the square root of x squared? X. Look at your signs. It's a positive C, so it matches B. What are we going to put? A plus. What is the square root of 121? 11. Done. All right, so what happens when A is not 1? Well, is 4 a perfect square? Yes. What is the square root of 4?
2x.
2, and the square root of x squared is x. Look at your signs. positive and positive, so we're going to put a positive here. What is square root of 9? 3. 2x plus 3 quantity squared. So the middle number, if you look back over at the pattern over here, it says 2 times a times b. So it's saying if I took my middle, or my parts that I just got, if I did 2x times 3 times 2, because it was a 2, and then this is my a and this is my b. 2 times 2 is 4 times 3 is 12x. And that's how you get your middle. So you can double check the middle. Most of the time it's going to be that way. This next one, it looks exactly the same, except now b is negative. So this first term still has to be a perfect square. And your last term still has to be a perfect square. The only difference is now, right, c is positive, so our signs are going to be the same, but now instead of a positive, it's going to be a negative. So again, we're taking the square root of the first one. Your sign is minus. We're taking the square root of the last one. And it's a perfect square, so we need to write it twice. So you can write a minus b times a minus b, or a minus b quantity squared. Signs are super, super important when factoring, whether it's a special case or just a regular one, right? So square root of x squared is x. Signs are the same, gonna match b, so it's a minus. Square root of 81 is 9, so x minus 9 quantity squared. All right, what about number 5? X minus 5 to the power of 2. Square root of 9x squared is 3x. Double check those signs. Minus square root of 64 is 8 squared. What do you notice here?
It's missing the middle.
It's missing the middle. So technically, if we were to look at this, this is really saying a squared plus 0ab, instead of that middle being a 2, minus b squared. Okay, so we're saying the middle is 0. So they're going to have to cancel out, which makes sense because look at the sign of our last term. What do we know about the signs when it's a minus? These are going to be different signs, which makes sense because if I add or subtract the same number, do I get 0? I do. So the pattern for this is a little bit different. These still have to be perfect squares. That's not going to change here and here. If I take the square root of a and I take the square root of b, but because this is a minus, we know our signs have to be different. So I've got a plus b, and I've also got a minus b. All right, we have perfect squares. That's what we want. But again, that sign is a minus. So that tells me I'm adding something and I'm subtracting something, right? My signs are going to be different when that last piece is a minus. We're still taking the square root. What's square root of x squared? X and x. And the square root of 36 is?
Positive 6 and negative.
So we have x plus 6, x minus 6. So if you think about that, if you were to multiply this through, right, we get x squared minus 6x plus 6x, there's your 0, minus 36. Okay, so that's why our signs are different. Looking at 8, again, you got that minus. So you got a plus and you got a minus. And we're just taking the square root. The square root of x is x and x. Square root of x squared, excuse me. And the square root of 100 is 10. Last one, the square root of 25 is 5. Square root of x squared is x. Look at your sign, it's a minus. What does that mean? We have a minus and we have a plus. What's the square root of 16? 4.